Hello students, welcome to the lecture on power and authority. After this lecture, you will be able to learn the following objectives. Understand the concept of quantitative techniques, explain the model building for business decisions, explain the role and scope of quantitative techniques, discuss the methodology of quantitative techniques, define the matrix algebra determination. Today we shall talk about quantitative techniques. Quantitative techniques are those statistical and operation research techniques which help in the decision-making process, especially concerning business and industry. Those techniques which provide the decision maker a systematic means of analysis based on the quantitative data in formulating policies for achieving predetermined goals. Concept of quantitative techniques. Quantitative techniques adopt a scientific approach to decision making. In this approach, past data is used in determining decisions that would prove most valuable in the future. The use of past data in a systematic manner and constructing it into a suitable model for future use comprises a major part of scientific management. For example, consider a person investing in fixed deposit in a bank or in shares of a company or mutual funds. The expected return on investments will vary depending upon the interest and time period. We can use the scientific management analysis to find out how much the investments made will be worth in the future. Now, there are many scientific method software packages that have been developed to determine and analyze the problems. In case of complete non-availability of past data, quantitative factors are considered in decision making. In cases where the scope of quantitative data is limited, qualitative factors play a major role in making decisions. Qualitative factors are important situations like sudden change in tax structures or the introduction of breakthrough technologies. In today's complex and competitive global marketplace, use of quantitative techniques with support of qualitative factors is necessary. Quantitative technique is the scientific way to managerial decision making, while emotion and guesswork are not part of the scientific management approach. This approach starts with data. Like raw materials for a factory, this data is manipulated or processed into information that is valuable to people making decisions. Model building for business decisions. Now, managers can be trained to make better decisions. They also need a supportive environment where they would not be unfairly criticized for making wrong decisions and will receive proper support from their colleague and superiors. A climate of criticism and fear stifles risk-taking and creativity. Managers will respond by playing it safe. It may also mean managers spend too much time trying to pass the blame around rather than getting on with running the business. Okay, now we shall look into the types of business decisions. We have programmed decisions, non-programmed decisions, strategic decisions, tactical decisions, and operational decisions. Now, programmed decisions are standard decisions which always follow the same routine. As such, they can be written down into a series of fixed steps which anyone can follow. They could even be written as computer program. Non-programmed decisions are non-standard and non-routine. Each decision is not quite the same as any previous decision. Strategic decisions affect the long-term direction of the business, whether to take over company A or company B. Tactical decisions are medium-term decisions about how to implement strategy. For example, what kind of marketing to have or how many extra staff to recruit. Operational decisions are short-term decisions, also called administrative decisions, about how to implement the tactics. For example, which firm to use to make deliveries. Now, this is normative model because it illustrates how a good decision ought to be made. Business studies also uses positive models which simply aim to illustrate how decisions are made in businesses without commenting on whether they are good or bad. Linear programming models help to explore maximizing or minimizing constraints. For example, one can program a computer with information that establishes parameters for minimizing costs subject to certain situations and information about those situations. Spreadsheets are widely used for what-if simulations. A very large spreadsheet can be used to hold all the known information about, say, pricing and the effects of pricing on profits. The different pricing assumptions can be fed into the spreadsheet modeling different pricing strategies. But it is very useful for management information to know what might happen to profits, what if a skimming strategy or a penetration strategy were used for pricing. Now, the computer does not take decisions, managers do. But it helps managers to have quick and reliable quantitative information about the business as it is and the business as it might be in different sets of circumstances. Basically, there are two types of constraints defined in decision making: internal constraints, external constraints. Now, internal constraints are constraints that come from within the business itself. Availability of finance. Certain decisions will be rejected because they cost too much. Existing business policy. It is not always practical to rewrite business policy to accommodate one decision. People's abilities and feelings. A decision cannot be taken if it assumes higher skills than employees actually have, or if the decision is so unpopular, no one will work properly on it. External constraints. These come from the business environment outside the business. Competitors' behavior and their likely response to decisions are business makers. Lack of technology. Economic climate. Some managers and businesses make better decisions than others. Good decision making comes from training of managers in decision making skills, good information in the first place, management skills in analyzing information and handling its shortcomings, experience and natural ability in decision making. Risk and attitudes to risk. Human factors. Emotional responses come before rational responses, and it is very difficult to get people to make rational decisions about things they feel very strongly about. Role and scope of quantitative techniques. Quantitative techniques sometimes require high quality data which are usually unavailable. A related observation which is often heard is that the better the data quality, the more obscure and complex is the analysis. In reality, both concerns are overstated. The case for seeking to carry out empirical analysis remains compelling for the following reasons. Many quantitative techniques can be successfully executed using fairly rudimentary data. Many of the available techniques can provide highly effective results with basic information. Second, it is undeniable that some of the more sophisticated techniques raise complicated technical issues and require considerable expertise on the part of the practitioner. However, precisely because of their sophistication, these techniques can yield exact answers to the questions that are pivotal to competition cases. Now, the scope and areas of application of scientific management are very wide in engineering and management studies. Today, there are a number of quantitative software packages available to solve the problems using computers. This helps the analyst and researchers to take accurate and timely decisions. A few specific areas are finance and accounting, cash flow analysis, capital budgeting, dividend and portfolio management, financial planning, marketing management, selection of product mix, sales resources allocation and assignments, production of management, facilities planning, manufacturing, aggregate planning, inventory control, quality control, work scheduling, job sequencing, maintenance and project planning and scheduling, personnel management, manpower planning, resource allocation, staffing, scheduling of training programs, general management, decision support system and management of information systems, MIS, organizational design and control, software process management and knowledge management. So from the various definitions of quantitative technique, it is clear that scientific management has got wide scope. Methodology of quantitative techniques. In solving problems, the methodology adopted is as shown in the flow chart. Formulating the problem, defining the decision variables and constraints, developing a suitable model, acquiring the input data, solving the model, validating the model, implementing the results. As a first step, it is necessary to clearly understand the problem situations. It is important to know how it is characterized and what is required to be determined. Firstly, the key decision and the objective of the problem must be identified from the problem. Then, the number of decision variables and the relationship between variables must be determined. In a given problem situation, defining the key decision variables are important. Identifying these variables help us to develop the model. For example, consider a manufacturer who is manufacturing 3 products A, B and C. Let A be X1, B be X2 and C be X3. X1, X2 and X3 are the 3 decision variables in the problem. The objective is to maximize the profits. There are 2 machines available, machine 1 and machine 2, with total machine hours available as 100 hours and 120 hours. The machine hours are the resource constraints. The third is developing a suitable model. A model is a mathematical representation of a problem situation. The mathematical model is in the form of expressions and equations that replicate the problem. For example, the total profit from a given number of products sold can be determined by subtracting selling price and cost price and multiplying the number of units sold. Now, accurate data for input values are essential. Even though the model is well constructed, it is important that the input data is correct to get accurate results. Inaccurate data will lead to wrong decisions. Solving is trying for the best result by manipulating the model to the problem. This is done by checking every equation and its diverse courses of action. A trial and error method can be used to solve the model that enables us to find good solutions to the problem. A validation is a complete test of the model to confirm that it provides an accurate representation of the real problem. This helps us in determining how good and realistic the solution is. During the model validation process, inaccuracies can be rectified by taking corrective actions until the model is found to be fit. Once the model is tested and validated, it is ready for implementation. Implementation involves translation or application of solution in the company. Matrix algebra determination. Let us now look at the matrix algebra determination. On the screen, we have a matrix. A matrix is just a 2-dimensional array of numbers. It is customary to enclose the elements of a matrix in parentheses. The elements of a matrix are a matrix which has only one row is called a row vector, and a matrix which has only one column is called a column vector. It is customary to denote matrices with more than one row and one column by bold uppercase letters. A square matrix has as many rows as it has columns. Let us now look at matrix addition and subtraction. To add two matrices, they both must have the same number of rows and they both must have the same number of columns. The elements of the two matrices are simply added together, element by element, to produce the results. Matrix subtraction works in the same way, except that elements are subtracted instead of added. There are several rules for matrix multiplication. The first is the multiplication between a matrix and a scalar. Here, each element in the product matrix is simply the scalar multiplied by the element in the matrix. The next rule involves the multiplication of a row vector by a column vector. To perform this, the row vector must have as many columns as the column vector has rows. The transpose of a matrix is denoted by a prime or a superscript T or T. The first row of a matrix becomes the first column of the transpose matrix. The second row of the matrix becomes the second column of the transpose. The transpose of a row vector will be a column vector and the transpose of a column vector will be a row vector. The transpose of a symmetric matrix is simply the original matrix. In matrix algebra, the inverse of a matrix is that matrix which, when multiplied by the original matrix, gives an identity matrix. The inverse of a matrix is denoted by the superscript -1. So, a matrix must be square to have an inverse, but not all square matrices have an inverse. In some cases, the inverse does not exist. The determinant of a matrix is a scalar. It is denoted as any of these two. For covariance and correlation matrices, the determinant is a number that is sometimes used to express the generalized variance of the matrix. That is, covariance matrices with small determinants denote variables that are redundant or highly correlated. Summary. Let us now summarize what we have learnt. Scientific methods have been man's outstanding asset to pursue an ample number of activities. Qualitative factors are important situations like sudden change in tax structures. The successful use of quantitative technique for management is solving complex problems on time with greater accuracy. Quantitative technique is the scientific way to managerial decision making.